So there's this idea that masks act as some sort of net that catches aerosols. That the aerosol that carries a virus, or just the virus itself, is smaller than the spaces between the fiber and the mask, that the mask will literally do nothing. In short, the perception is akin to a mask working like a net that only captures the aerosol that is larger than the distances between the fibers. Now, if this were the case, aerosol would never deposit in the lungs since the airways are much, much larger than the virus containing aerosol. And since we know that these virus aerosols do, in fact, deposit in the lungs, this assertion is simply ridiculous. So then, how do masks trap aerosol? Well, shown here is the deposition fraction versus aerosol size for the simple cloth and surgical masks. And here's the deposition fraction versus size for the more efficient N95 mask. Do these graphs look familiar? They should. Here's the deposition fraction versus aerosol size for the lungs that I showed earlier. These figures are very, very similar. And the reason that these two figures are very similar is simple. The mechanism of aerosol deposition in masks and in the lungs are largely the same: impaction, diffusion, and sedimentation. Note that masks have an added feature to increase their filtration. And for both, as soon as the aerosol contacts the surface, it sticks. So in both masks and lungs, the aerosol larger than about zero point 0.5 microns is deposited via impaction and sedimentation, and the aerosols smaller than about zero point 0.5 microns are deposited by diffusion, and this leads to the characteristic minimum deposition fraction of around 0.2 microns. So the physics, the weird, wonderful physics of aerosol is the same for both systems.